So you have 7 questions. All right, so let's do this. So the one thing you want to do, and you want to create a table. In a second, I'm gonna run out of room, guys. In a second. So I can push this to the right. Push this like this. Okay, I can do that. Push this and go to pages. So I do it like this. All right. So we have a car. A and what? A is 60 miles from B. Okay, so I want to draw this out. Looks kind of weird. Let me make this a little smaller. So we have A 60 miles from B. So let's draw this out. So this point A, point B. I know the distance is 60 miles. Okay, and then there's a car, let's say, that is going that way at 20 miles an hour. 20 miles per hour. And at the same time, there's a car B on this side that's heading that way and at the rate of 25 miles an hour. Okay, so that's what's happening. So that's just a drawing to help me visualize what's happening. So I'm going to create that table, right? So I know, Christian, you were not there. So the table, let me create a generic table. So the table is going to be about. So here we're going to put car A, car B. Okay, so it could be car A, car B, jogger A, jogger B, or runner A, runner B, or something, but it's A. First column is your rate, right? And in terms, in this case, the speed. So A is driving at 20 miles an hour. B is driving at 25 miles an hour. Sorry, I should have written car A, car B. That's right. The second column is T, time. We don't know when they're going to meet, so that's what we're trying to find out. So car A is going to drive for 20 miles. It's going to drive 20 miles an hour for a certain time T, and B is going to do the same. Okay, and they're going to meet somewhere in the middle. Okay, not crash, but they're going to meet. No, well, not in the middle, sorry, but somewhere more to the left of the middle because car B is a little bit faster. Okay, so my apologies. Now, what you do need to know, Cristiano, is that distance is rate times time. So just as an example of that, let's say you run at 5 miles an hour and you run for 3 hours. How far did you run? Well, so if you use the distance formula, distance is the speed you're running at times the time, in this case 3 hours. We can say that after 3 hours you ran 15 miles. Okay, so that's what this means. So this column is called your distance column. Distance, like I just showed you, is r times t. So let's multiply r times t. So the distance for car A is 20 times t, right, or 20t. And the distance for car B is 25t. Now, what do I know about their distance? I know that the distance traveled by the first car, let's just say that he traveled all the way here. Let's say this is the meeting spot, okay? This distance traveled by car A, and this distance traveled by car B. What do I know about the distance? So if I add the distance that car A traveled plus the distance car B traveled, I know that equals 60 miles because that's how far apart they are. So I can use that information to set up my equation. So I'm going to say distance of car A, which is represented by 20t, plus the distance of car B, which is represented by 25t, equals 60 miles. That's it. Now we combine like terms, which is 45 over t, which equals 60. And then divide both sides by 45. And t equals 12 over 9. And we're going to divide that 4 over 3, 1 1/3 hours. So when did they meet? They met at 1 1/3 hours. Okay, and then I'm gonna check this. I'm gonna take this one step further. We don't have to do this, but if I wanted to check, let's just see if that makes sense. So, but instead of 1 1/3, I'm actually gonna write 4/3 of an hour. 4/3 hour. Okay, because it's probably easier. Now let's take car A. Car A is 20 times t. or 20 times 4 over 3, and that's going to give us 80 over 3. Car B is going to travel 25 miles an hour times the t, which is 4 over 3, and that's going to give me 100 over 3. Now, if I add those up, right, here's the distance traveled by car A, which is 8 over 3 miles, and the distance of car B, which is 100 over 3 miles. So 80 over 3 plus 100 over 3 equals 180 over 3. And that distance is 60 miles. That tells us that we are correct. So car A, which was the slower car, drove 80 over 3. You could change that to a mixed number if you want. And then car B drove 100 over 3 miles, which is whatever, 33 something. Okay? But the important thing is that when I add them up, it does give me the total of 60 miles. Okay? Number 2. So, number 2. Oh yeah, I have 2 autos again. Okay, so again, same scenario. It's 276 miles apart. Let's call this A and B again. So car A is traveling, and I know they travel for 6 hours. They meet after 6 hours. So what's the speed of car A? I don't know. And the difference, they differ by 5 miles per hour. So let's say car A is traveling at R miles. Okay. The other car is going to be R minus 5, because they're different by 5 miles. Okay. So that helps me set up my table. So car A, car B, remember we have a table. The first column is going to be the rate, the second column the t, and the second column the d. So car A is traveling at that speed. Car B is his speed minus 5. The time that they drive for, does it say? Yeah, they drive for 6 hours. And the distance now, remember the d column, we're always going to multiply r and t. So for A, the distance is represented by 6r, right? 6 times r. And for B, we're going to use the distributive property, 6. So think of it as this. We're going to get 6r minus 30. Okay, so what do I know about the distance traveled by car A and the distance traveled by car B? I know that if I add them up, because they meet somewhere, right? They meet at some point. So the total distance that they covered combined equals 276. So I'm going to take this guy over here and this guy and say that the sum of their distances equals 276. So you're going to have 2 options basically a lot of times. Either you're going to equal to a certain distance if that's given to you, or their distance is going to equal each other, which is not the case right now. Okay, so continue with this. We get 12r minus 30 equals 276 plus 30 on both sides. 12r equals 306. Divide by 12, divide by 12. I have no idea what that is. Please give me a nice number. 306. 306 divided by 12, 25.5. So R, the speed of one of the cars, is 25.5. So you can call A the speed of R. So we come back here to our table and we substitute. So A was traveling at 25.5 miles an hour. And the other one is going to be 25.5 minus 5, which is going to make that his speed 20 miles an hour. Okay? Not that bad. Question 3. Okay, another 2 trains situation. Okay, so hopefully there are different questions. So 2 train situation again. I know that they are 195 miles apart. One train is going at 25 miles per hour that way, and the other train is going at 40 miles per hour. If they start at the same time, when will they meet? Okay, so T is our incognito. So let's call this the fast train and the slow train. Okay. So the fast train is going at 40 miles an hour. The slow train is going at 25 miles an hour. Time-wise, I want to know when they meet, so it's in, I don't know. And the distance is going to be the product. So it's going to be 40 times t, which is 40t, and 25t, which is times t, which is 25t. Now, the sum of this distance, the sum of the distance traveled by each train equals 195. So whatever the train, right, 40t, the train, the faster one, plus the distance of the slow train equals 195 miles. 65t equals 195, and this is going to give us a very nice number, which is in 3 hours they meet somewhere around here. Okay, so and then if you wanted to confirm, okay, just to make sure, so let's take a look at the fast train. The fast train, the distance is 40 times t. If I substitute, I get 40 times 3, and that means that that train traveled 120 miles. The slow train is 25 times t, and 25 times 3, t equals 3, 25 times 3 is 75. So that means the faster train traveled 120 miles. Let me just write this, 120 miles. And the slow train traveled 75 miles, and they met right here. Okay. So, and again, if you add 120 plus 75, does that give us our total distance of 195? Yes, it does. So, again, you can take that step to verify your answer. Where am I? 4. Ugh. Again, so now they're becoming repetitive. They're going towards each other, A and B, and they're 150 miles apart. A was at 20 miles an hour. B, we don't know. Okay, so we'll call that R. And they want to meet in 5 hours. So how fast does that train have to be to meet in 5 hours? A little bit different. A, B, so what's the distance? That's an R. The speed is 20 for this guy. And the other one we don't know, so we'll call it R. The time, we want them to be both traveling in 5 hours, for 5 hours? 5 hours, times 5 hours. And the distance, so now the D is going to be 20 times 5, which is 100. And R times 5, which is 5R. Right? So we multiply R times T. So I know that the distance that each travel has to be equal to 150. So the distance of the first train, which is 100, plus the distance of the second train, which is going to be 5R, it's going to equals 150. Okay. Subtract 100 from both sides. 5R equals 50. Divide both sides by 5. R equals 10. So the second train, we go back here, right? Second train, his speed has to be 10 miles an hour. Okay? And that makes sense because if you plug it in here, right, 5 times R, for 5 hours he's driving at 10 miles an hour. That means that he's going to cover 50 miles. The first train already covered 100. The second train covers 50. So notice that this and this gives us a distance of 150. Number 5. 5. 5. 5 says a passenger. Okay, again with a train. So let's call this a passenger train. Let's call this the freight train. They are 300 miles apart. The passenger train exceeds the rate of the freight. So the freight train is just R. We don't know its speed, but we know the passenger train is faster than that. So it's going to be R plus 15. And they travel for 4 hours, right? And so we're going to go and meet. So let's call this passenger train, freight train. Change colors. So the passenger train is traveling at R plus 15. The freight train, his speed is 15. The time, what is the time? 4 hours for both. And D, all right, so D is going to be, well, let's do the easy one. 4 times R is 4R. The top one is just distributed property. 4 times R is 4R plus 4 times 15, which is 60. And once again, the distance that they each travel combined will give you a total of 300. 8R plus 60 equals 300. Combine like terms. Minus 60 on both sides. You get 8R equals 240. Divide both sides by 8. R equals 30. So the speed of the freight train is 30. The speed of the of the train above is going to be 45. Okay. And again, you can substitute this also over here in the distance. Right? So if you substitute here, it means that the freight train 4 times 30, right? 4 times 30, the freight train is going to travel 120 miles. And on top, 4 times 30 plus 60 is going to be 180. So then the passenger train is going to cover 180 miles. And look, 180 plus 120 is 300. And again, that's another way of checking. Okay. I honestly don't like these questions. I had a feeling they were different. 6. Finally, 2 cars. One's going this way, one's going that way. Let's call this a 25. So A is the slow. B, let's just call it fast and slow. How's that? The fast one's going that way. It's 35 miles an hour. So after they stopped at some point and they're 180 miles apart from each other, right? So they eventually get that far apart. After how many hours did they reach that point where they were 180 miles away from each other? So the slow train, fast train, just another chart. So the speed of the slow is 25, the speed of the fast is 35. The time is what I need to know, so TT. The distance, 25t, 35t. Oops, forgot T. So however much this train traveled plus however much this train traveled, if I combine them, it equals to 180. So 25t, 35t equals 180. That is 60t equals 180. I divide both sides by 60, and t equals 3 hours. So after 3 hours, they were 180 miles apart. To confirm, right, so I know t equals 3. I can now go back to my distance column and substitute. So 25 times 3, 75. So that train travels 75 miles. 35 times 3, over here, it gives me 105. And guess what? Those two do add up to 180, which is how far they were. I'm a little disappointed with the questions. All right, so a man having 10 hours at his disposal made an excursion, riding out at the rate of 10 miles an hour and returning on foot at a rate of 3 miles an hour. So okay. So let's make this start. Okay. So he went this way, 10 miles per hour, that's his speed. Okay, I'm gonna have to pause this video because I don't have the rest of the question, right? And I need to attach it to you guys. Okay, so now I have. So I have, okay, so a couple of things, couple of comments. I found out that there's a second page that I didn't assign and I just forgot to see it. So you're okay. We'll do the first 7 and on Monday you'll do the second page. So for question 7, I just fixed it. It's to find the distance he rode was the sentence that was missing. So let's get started. So a man having 10 hours, so we know the time is 10 hours. He's made an excursion. So he's going to ride his bicycle for 10 miles an hour. Okay, and then returning on foot. So wherever he went to this place over here, and then he made U-turn, came back, but he came back walking at 3 miles an hour. Okay, obviously, his return time was definitely longer than the initial time, right? So going was faster, and then coming back took a long time. So we know that the total hours was 10. This whole trip took 10 hours. So okay, so find the distance he rode. For how long did he ride his bike? Well, let's do the chart. So let's call this the bike segment, and then the other one is the walking segment. So for the bike, his speed was 10, his walking was 3. For time-wise, let's call the time that he took on the bike of t. And therefore, the walking time would be 10 hours minus however long he was on the bike, minus t. Okay, that's what we'll call it. So d, we multiply, 10 times t is 10t. 3 times 10 minus t, remember we're doing distributive property, so we get 30 minus 3t. Okay, so what do we know about, do I know the distance? I know, oh, here's what I don't know the total distance, but I do know that the distance that this distance right here that he was spent biking going that way, and the distance that he came back, they're equal to each other, right? Because it's just a return trip. So when I set my equation here, I'm going to set that 10t, my going there, the distance he was on the bike, is equal to the distance he walked. Okay, so now it's just a matter of simply solving this. So we have t on both sides. Let's get rid of 1. Plus 3t plus 3t. We get 13t equals 30. And our time, ugh, what a horrible time, is, what am I doing here? Equals 13. So t equals 30 over 13. I'm not going to leave it over here. So that's probably 13, 2 hours, and 26, 4 over 30, or 2 over 15. So, but I'm going to leave it over here like this. And I just want to double check. Okay, so the time he spent on the bike, well, actually, let's change that. It's 2:26, 4 over 13. So that's how much he spent, on the bike, and then walking. So I'm going to write 2 hours and 4 over 13 minutes. And then this would be 7 hours, 6 over 13 minutes. Okay, be walking. All right, and I just want to double check because I want to, because I remember. So the distance, let's go for the distance. They have to be equal to each other. So if I multiply 10 times, what was the number? 30 over 13. If I multiply 10 times 30 over 13, it has to be equal to 30 minus 3, 30 over 13 times, by the way. So over here, can I simplify it? I get 300 over 13, which I'm fine with that. And here I get 30 minus, what number is this? Hang on a second. Right, because t is 30 over 13 times 30 over 13. Hang on. This is 90 over 13, so we need to do a thing on that side. So 13 minus 90. What is 300 times 13? No, 30 times 13. 390. And they're equal to each other. Perfect. So we know we're good. Okay, that's just a check. So the distance traveled on both sides is the same. Oh, thank you. All right, so